Wonderful good afternoon, dear LinkedIn community and Composites Lounge members. This is now day 2 with Diamond Aircraft, and now we have completed Diamond Aircraft composites production, and we did our test flight with the chief pilot, and now we are back on the ground with Austro Engines. And this is basically the supplier of the nice engines to Diamond Aircraft. And together with me, I have the honor to see the Managing Director Jürgen Schwarz. Jürgen, thank you for being part of our show.
Yeah, welcome to our nice facility.
This is the first time I'm actually talking to an engine manufacturer who is supplying the aircraft industry. How long do you do that, if I may start with a personal question?
I'm in the business since around about 15 years. I started my aviation career with Continental Aerospace Technologies, a short time at Red Aircraft Engines doing a big V12, and since 1st of January 25 I'm here.
Wow, that's a brilliant aviation history. And I may ask you, do you have a passion for flying?
I have passion for flying. I don't have a pilot license myself, but I have the opportunity to fly also the Diamond aircrafts whenever I'm interested in.
Wonderful, yeah, and you have also a nice scenery here. So let's dive into the company, Austro Engines. Tell me about your company and the product portfolio, and the strategy would be very much interesting.
Yeah, we are. Austro Engine is located here in Wiener Neustadt, very next or very close to our friends of Diamond, our mother company. We have around about 130 employees. The main department obviously is engine development, so the so-called DOA, design organization, and as well the production organization, and then obviously surrounded by supporting functions like HR, finance. So we have everything we need. What we are not doing, we are not machining any parts, so we are not manufacturing engine components. We only assemble the engine here in our facility.
This sounds only like this is a simple task, right? A simple job, but of course it's not, yeah? So you have a supply chain, a complete value chain set up.
Yes.
Tell us about how you manage this value chain, and where is this value chain from?
Yeah, supply chain obviously is the challenging part. Yeah, so our supply chain is mainly located here in Europe. All core components are produced, let's say, in Germany, Italy, Austria. So we are very focused that we purchase as local as possible. Yeah, for us it does not make a lot of sense to purchase anything overseas. It's just too complex for our small volumes. So that's why we try to get everything in a distance, let's say 1,000 kilometers, 500 kilometers. This is perfect environment for us.
And also this makes it flexible to respond to anything that may be going out of control, supply chain issues and things like that.
Absolutely.
Having the local sourcing makes total sense. So tell me about for example, the aerospace industry, of course, is the major certification industry. Everything has to be certified. So do you get gray hairs when certification people come to you and audit you?
Not really.
Not really.
No. We have quite a very good working relationship with our authorities. Let's say EASA is the major authority, and ACG, the Austrian authority, mainly for production. So this is kind of like day-to-day business. We keep a very close relationship. Typically we can do a lot simply by phone calls, keeping the authorities in the loop from day one. We are planning to do any changes or if we have any problems, and this is typically the key, keeping a good relationship to the authorities. Let's say if it comes to a full new development of an engine, the process is so described, so how to certify an engine. Also this normally is not creating any gray hairs for us. It's obviously it's a lot of work to do, a lot of documentation, a lot of preparation, but the process is very well known. It's completely different if we would enter new areas of certification, for example, certifying an H2 engine. So because there is no rule making yet, done for such an engine. And this is obviously much more challenging because then you have to discuss rulemaking with the authorities, and rulemaking obviously needs to fit everyone in the industry, not only us. And then it becomes really complex and time consuming.
My colleague Norbert will dive with you into hydrogen a little longer or a little later also. So now you've been, let me take grab the chance. So you are quite a few years in this aviation industry. So if you compare aviation 15 years ago, or maybe even prior to that, what has changed recently?
Yeah, this is, in my terms, let's say, it's not really a problem of aviation, but the innovations is fairly slow. Yeah, if you really look, kind of like as I grew up, aviation at Continental, we had both gasoline engine as well, the Jet A powered engines. And if you look at the gasoline engines, I would say there was no innovation in the last 40 years, mainly. You barely see engines with a full engine controller. Still you see very simple injection or even carbureted engine. I think the biggest innovation, not only Austro, all other companies kind of like invented the Jet A powered piston engines again, because all these engines are FADE controlled, so ECU controlled, and I think this really brought a big portion of, in one area, safety to the additional safety to the market, I have to say, but also some innovations, because now you have a modern engine where you don't need to care about mixture control and starting the engine. So this is all like we are nowadays used from cars. And so, but I definitely would not say that the engine manufacturers in aviation are innovative compared to the automotive industry or even to motorsports. So we are decades behind.
So it's an honest statement from you, but you see community, I have this, I'm from the textile industry, not from mechanical engineering, but from textiles. The seating in an aerospace, in an airplane, for example, these are specs from 1982. The textile industry has evolved much further than that. New fire-resistant textiles are available, but they are not spec'd in, so they cannot be used. But what it is, of course, they have been proven, they have been tested, and there has been no issue with it, so they carry on using these textiles.
Correct.
And this is a problem, most probably with engines, many times more even. All right, Jürgen, thank you so much for this introduction into Austria and Austro Engines. My colleague Norbert will take over now, and he will dive with you a bit into the technology of engines.
So thanks, Mr. Schwarz, for being also with the Jet Circle here today and giving us a little bit of insights into Austro Engine and the airplane engines that we just experienced in our flights now with the DA62. So give us a bit of background, maybe. What are you producing here? What are you assembling here in Austro Engine?
We have one major type of engine we are producing. It's our inline four-cylinder diesel engine, so it's an internal combustion engine. Very similar technology what is used in the automotive industry. So it's a high pressure common rail diesel injection type. So injection pressure is up to 1,650 bars. So this is state of the art, I would say. And we have a smaller engine, a rotary engine, which is mainly used, or let's say our main application is for glider. Power for gliders. So these are the two engine types we are producing here. The inline four-cylinder engine is produced in 4 different variants, which is mainly driven by in which aircraft it goes in and which horsepower output the engine has to produce.
So why 4? That's of course the 42 and 62, but where is the additional?
The 40, 42, 62, one variant of the 40. So we have, I think, 2 variants on the 40s.
So, and both of them are here, right?
These are only demo engines. So this is mainly for people coming in, explain a little bit the generals of the engine. So we do, because from the outside the engine, they look so similar, there's no need to put 4 look-alike engines in one row.
Okay, and you said it's coming from the automotive industry. So I think in the past I heard it was always the Mercedes C-Class or so. The 2-liter engine was pretty much similar. Or which class was it? Which engine was it?
I think it was an A-Class engine. A-Class engine, correct. The point was the core engine was original automotive engine, and Diamond or Austro Engine decided to convert this engine in an aviation engine. There's one one big advantage to go this path, you build your engine on a proven technology already instead of drawing everything from scratch.
Yeah.
So this speeds up the development process typically quite a bit. We are now in the phase where we do not source any components anymore from the original manufacturer, so from Mercedes. So we have our own sourcing supply chain. So each and every component is fully under our control in terms of design, drawings, and supply chain.
Yeah, and that means also where are those components mainly coming from?
Most of the components, or nearly all components, are produced and sourced within Europe. So we have nothing overseas from overseas, and this is all around, let's say, in an environment 1,000 kilometers around Wiener or Wiener Neustadt.
Tell us a little bit, like you said, 150 people are here. That's partially production, partially then the design organization. How is that? How many engines do you manufacture? How is the distribution between production and engineering there?
Yeah, our run rate is round about, so at the moment we are at the run rate of, let's say, 900 engines a year.
900.
Yeah, so obviously in this production environment, let's say in one shift we could go up to 1,200 engines a year. If we need more, then obviously we had to introduce maybe a second shift or half a second shift or whatever. We are not using Saturday, Sundays, so it's a normal working day for all our employees. The split between engineering and operations is about 40 to 60%, so 40% engineering, 60% more production related. So you can see we are quite heavily engineering loaded, but this is also driven by the demand of the authorities.
So that means you could scale the production here still quite flexibly up and down from the 900 as you needed.
Absolutely, yeah. Typically we can scale up and down as needed. So let's say if you would look at our week-to-week production, it's quite flexing a bit. Yeah.
Ilkay Özkisaoglu at Aero 2026 with Composites 360 on tour. Materials, structures and engineering decisions. This is why I'm here, to cover you these decisions that have to be made regarding engineering, technology and sustainability. I'm Ilkay. I focus on the engineering side of aviation. I'm mostly interested in how these things get to fly. The manufacturing side, technology and engineering. Innovations that make these gears fly. Real teams, real technology, real innovations. Composites, components and cutting-edge engineering, that's my world. Join me when we go into the details. Jets, components, communities, all in one place. The topics in aviation that are trending right now, of course, are sustainability, MRO, maintenance, repair, overhaul, and also retrofitting these planes. And all these have to be lightweight, of course. That's why we're here, covering the stories for you from Aero 2026, ILA in Berlin, and maybe other places like Paris Air Show next year. Why are then aircrafts one of our major topics at the Composites 360 on tour coverage? Because these things are technical gears and they combine all processes that are in the lightweighting technology available. So whom do we service this for? If you are in the aviation industry, aerospace industry, but also in the automotive industry, all these parts that you are seeing here on the wings and on the winglets are made from composite materials, lightweight technologies. And we cover in the aviation, of course, not only the outside or the engine compartment. Of course, very important is also the inside of the plane. And sizes, of course, start with the small to the mid-size range and to the large. Whether it is brokers or operators or MRO companies like Lufthansa Technik, these are part of our coverage. Follow along, we are just getting started. And we partnered up in the general aviation with the Jet Circle. And the Jet Circle is about?
The Jet Circle is the whole world of business aviation, bringing you most efficient propellered airplane or a nice business jet like this one behind us.
And I bring you engineering and components, technology with the Composites Lounge onto your feet. At the body of our newsletter, you will find all videos and YouTube and podcasts and get yourself a picture out of what's going on in the general aviation industry.
But what is then the main constraint in this, like the sourcing of material? Because everybody hears now that all the manufacturers of engines have either computer parts like chips for the control mechanism is missing, or certain parts are missing. Is that an issue for you with the supply chain?
No, for us, let's say in terms of volume, the supply chain is not a problem, because we would not go from 900 engines to 9,000 engines. Yeah. This is unrealistic. So for us, a higher demand would already be going from 900 to 950 or 1,000 engines. So this the supply chain can cover very well. Obviously, it needs a little bit pre-preparation, but internally, for example, the engine testing would be a bottleneck. So as we only operate 3 dynos for serial production, so this would become one of the first bottlenecks, that maybe we need to have higher capacity in engine testing.
So how is it now if somebody has a broken engine? Is he having a quick then delivery time from your side, or does he need to wait long time, or from Diamond side, whoever needs to deliver the engine?
No, normally we try to keep at least from each of our engine models 1 engine here on stock. We call this AOG engines, which then in an idle world can be shipped within 24 hours.
Okay. Let's go also more into the future, because often the engines are now talking about, okay, we have not anymore the leaded fuel here. We have now already kerosene Jet A1 engines, but the future is also going to hydrogen or more electric aviation. Where is Austro Engine standing there, or what do you do there?
Yeah, obviously we are not that deeply involved into electric aviation. In terms of powertrain, we support Diamond where needed, but it's currently not in our focus to produce electrical motors. So that's not in the scope. But we are a strong believer that the piston engines will survive maybe another 40 years in aviation. So I'm not very concerned about this. Near-term future definitely is sustainable aviation fuels. So this is where we mainly concentrating. So we are part of different committees, also the ASTM, meaning also in the rule making for sustainable fuels, to make sure that not only turbines are under the radar, that also piston engines are under the radar, because compared to turbines, we have 2 major factors. We need to be sure we need a certain SAF number so that the engine still will self-ignite. This is a very important characteristics of the fuel, and also the lubrication factor, as we have high, like I mentioned, components carrying the fuel with very high pressure, so we also need lubrication in the fuel. This is our main focus. So far, all future sustainable fuels, or I would say the fuels which are available and can be produced, they will fulfill the spec we need. But anyway, we need to track this a little bit.
Yeah, that's what I wanted to ask now. So on today's production slots of sustainable aviation fuels, like OMV is here in Vienna, for example, producing, would the engine cope with 100% of this fuel, if it would be possible in aviation to do 100% into the tank of this SAF?
At the moment, let's say approved jet fuels is only blends with 50-50. And all the blends which are certified, we can use them without any question at the moment. It's more really looking into the future when it gets 100% SAF, and then we need to make sure that the fuel characteristic fits to a piston engine.
So that's still questionable if 100% SAF would be fully okay with the engine?
Yes, from an engine perspective, I think the risk is fairly low, because the demand of Jet A fuel is so high that maybe in the foreseeable future it's very questionable if we can produce all the amounts which are needed.
Absolutely, but like we had also a client just 2 weeks ago that was really demanding us to fly on 100% SAF. Of course, not in the tank, but at least backed by 100% SAF. So our operator purchased with OMV the amount that was appropriate to the overall CO2 emissions that this whole flight would have done. And so so that's why some clients would be also happy to have 100% SAF in the tank, in the actual tank of the airplane, but that would be at the moment need to be a plan because of certification.
It depends a little bit. If it's, let's say, one specific customer who's operating, let's say, out of one location, or one operator who can say, I can guarantee that I always get the same sustainable fuel, we would be able to do a special application for him, or check the fuel for him, so that he can get a special permit, for example, also to fly already now with 100% of SAF.
50-50 is no problem at all.
If it's a certified Jet A fuel, so it needs to be certified Jet A fuel based on ASTM standards.
Okay. Anything in the hydrogen area that you are doing?
We are looking in hydrogen, not by ourselves. So these are we have several programs, joint programs with universities, as they are much better equipped for hydrogen than we are. We have a close relationship with the Technical University of Vienna.
Okay.
So they run a single cylinder and a 4-cylinder hydrogen engine based on the Austro Engine, as well the University of Dresden. They are entering into a project using a DA62, which should be converted then to a hydrogen airplane. Obviously, this is a long-term ongoing project. It will take a while also on the aircraft side, but this is definitely something we are looking into. We are maybe a little bit special because our concept is to offer a dual fuel engine, not only hydrogen, so we still would carry kerosene on board. And for us, this is more like for the customer to be able, if the project materializes and the customer is flying a hydrogen engine and he has to land somewhere where he only can get jet fuel, he would be able still to operate his aircraft.
It would be both possible, like a hybrid.
Exactly.
We heard from Martin during our test flight that the airplane engines are extremely efficient with really low fuel consumption and extremely good power output. What is making it so efficient? What is the reason for that? Give us a background.
This is really based on the automotive technology, due to the case that we are using a common rail injection system. So we are able to vaporize the fuel very efficient to the combustion chamber, and we are able to burn every single drop of the fuel due to this high pressure. We inject the fuel, and then we can create a very high thermal efficiency. And in the engine business, we typically talk about grams per kilowatt, so specific performance. And our engines typically about 210 grams per kilowatt hour output. And if you compare to a turbine, they are, for example, more like on 400 grams, so 2 times more. And also here we have to put this in a perspective. As bigger a turbine is getting, as more efficient the turbine is. This has to do with some thermodynamics of a turbine, but a turbine in a 400 horsepower class is quite inefficient, for example.
And how is it with comparing this to like a normal piston engine from Continental, Lycoming and so on?
If you compare it against an older F-gas engine, obviously we are more efficient. Let's say our Jet A powered piston engine is the same like the Continental or like the Red, because we are all using the same principles. So maybe here we talk about 1 or 2% of differences, maybe in specific points. But that's not the point. The big difference is compared to the older F-gas engine. And if someone would take the money nowadays and develop a brand new gasoline aviation engine, let's say based on modern automotive technology, they would be also very efficient, just because the technology is available nowadays, which was not available maybe 40, 50 years ago.
Even this engine is still a bit older technology, even because what 90s or so A-class was using. Okay, very good. So I think we got a really nice wrap up of what you are doing here, and now we will see a bit more from the actual production here.
We start our tour through the company in the warehouse. So in the warehouse, all the parts are stored after incoming inspection and checking. So whenever a part is here, it's already released for production. So in our warehouse, it also takes place the commissioning for each engine. So you will see later on in the production, so one mechanic is building one engine and he gets all the part ready commissioned for his engine. So we don't have any Kanban system or so. Everything is commissioned based on a production order.
So did I understand that correctly, that one technician gets all the parts for all the engine and then he starts doing the whole process through? So it's not like different stages where different people are then doing the engine.
We only have two main stations. We call it the core engine and then the final assembly of the engine. So it's mainly more or less two mechanics on one engine working.
So core and then later the assembly of all the additional material around it.
Yeah, and on these trolleys, the parts are pre-picked from the warehouse and just waiting for the mechanics. They pull the car, they pull the trolley, and then they bring it to their workstation.
So one trolley is one engine full, or what? Or several trolleys?
Several trolleys are getting to one engine, correct. Then the mechanic typically starts with a crankcase. He puts the crankcase on his assembly tray, and then he assembles step by step the engine. Whenever there's a specific step where he needs a second control phase, he's calling an inspector.
Okay.
And then an inspector will come to his place, and then they assemble, let's say, doing a special assembly process with a 4-eyes principle, and then the inspector has to sign off that maybe a bolt was torqued or a component was assembled to the engine.
How long does it take one mechanic to build one engine?
It's the whole round is about something around about 12 hours in total to build one engine, but not by one mechanic. Really total working hours.
And so 12 hours of total working time, and one engine is going off.
Correct.
And it starts from like the crankcase.
Exactly, like having the crankcase assembled to the... Here we have the crank already in the crankcase, so that's already the maybe fifth or sixth step. As an example, one of our colleagues is currently preparing turbochargers, so it's an assembly process. So once a turbocharger is completely assembled, it goes back to the storage room and then waiting for the production order.
Okay.
So in these stations, here the engines, they got, let's say, more individual, because here the big difference is, for example, what you can see here, the engine harness, and the engine harness obviously is related to the aircraft the engine needs to go in. So once an engine is here, it's already clear in which aircraft type the engine will end up. Some hardware components are a little bit different.
But the block is the same, or what?
The block is the same, cylinder head is the same, so really the big core components are all the same. And then obviously it's the mapping is different, and then some little details on the engines also describing the horsepower. Once an engine is fully assembled, we put it on a special dyno rig. So it's fully installed, fully filled with all the liquids, cooling liquids, everything we need to operate the engine. Then the engine is brought into the test cell, and then it becomes a running in procedure, which is around about 1.5 hours.
Okay.
Running in, starting with very low performance, going up to max performance, and then as the final approval, a full performance curve. Performance curve in aviation is kind of like a must. It's described by the authorities, or the authorities ask for it, so that we can guarantee that the engine is in a certain limit. We are not allowed to have less performance, but we're also not allowed to have more performance. So we need to be in a specific bandwidth.
Okay, and that will be checked during the engine
Correct.
test.
Exactly.
How long does the engine test take overall?
So round about in and out, I would say it's around about 2.5 to 3 hours, including installing the engine on the dyno.
And how long is the engine running then, really?
It's 1.5 hours for the kind of like running procedure, break-in procedure, how we say, and then maybe another 10 minutes for the calibration curve. So once the engine is released from the dyno, here we do kind of like the final inspection of the engine. So it's checked that all parts are there, all liquids are drained, and all the accessories are also put into the boxes. And then the engine is signed off. and then we cover the engine and it's ready for shipment.
Okay. Well, shipment is usually not that far, isn't it?
It depends. If it needs to go to Canada, our production plant in Canada, obviously it's quite a distance, or to China.
Yeah.
Yes, we have production plants there as well. If it only goes to Diamond Austria, obviously it's just around the corner.
Well, it was wonderful to see all the stages of the production of such an engine. Now we understand much more and see how you do the reliable Austro engines here for the Diamond aircrafts. So thanks a lot, Mr. Schwarz.
Thanks a lot.
And
Hope to see you again.
hope to fly with you again soon.
Sure. Thank you.
How do we connect you with stories within the composites and sustainable materials industry? We are on the ground to find the facts. We examine big, innovative ideas. We let diverse perspectives on technology and sustainability emerge and ignite conversations that matter most to bring you the composites and sustainable materials world. Stay informed, stay connected, stay inspired. From our online studios in Germany, covering events and corporates from France, Italy, UK, Central Europe, and many more European regions. Join us for creating sustainable value.
With Composites 360 on tour, Composites Lounge engineering talks, and Composites Lounge end user panels hosted by Ilkay Özkisaoglu. Weekly on LinkedIn, YouTube, and your preferred podcasts.